Hi, my name's Phil McAleer. I'm from the University of Glasgow in the School of Psychology. And this is a presentation on how we've updated our curriculum over the past few years to really focus on the idea of reproducible research. To start off, to maybe give a bit of a historical viewpoint to show you where we were a few years ago, this will be familiar to many of you, but in about 2015, this paper came out from the Open Science collaboration, and it was looking at the idea of the replication of effects in psychology. It made quite a splash, and as sure many of you will know, it roughly found about 2/3 of the research that it tested wasn't reproducible, and we couldn't find the same, or wasn't replicable, and it couldn't find the same effect as had previously been stated. So this caused quite a discussion in psychology about where was the field actually going and how well were we doing in producing research that actually would stand the test of time. Not long after that, there was research and papers written about how we could actually improve our field. And this one from 2016 in the British Psychological Society magazine, The Psychologist, from Kate Button at Bath and colleagues, was really trying to get at the idea about how we can improve our teaching. And really the concept of the idea is really that if you build better undergraduate students with better skills, then you will lead on to an improved future in the field. Okay, so changing the culture of how we teach undergraduates in psychology, instilling the principles of transparency and scientific rigor at the grassroots should in theory lead on to a much better future of the field. And again, if you kind of think about where we were meant to be hitting in terms of what our students should be leaving our degrees with, this is from the subject benchmark statements in 2016. And it was saying that really, in terms of kind of reproducibility and research methods, students should be able to individually demonstrate a range of research skills, including planning, considering and resolving ethical issues, and analysis and dissemination of findings. So if you couple all that together, we know that there's issues in terms of reproducibility in the field. We know that students should be getting taught a range of skills that would help them resolve those issues. But we had to also have a stronger self-reflection about whether we were actually teaching those skills and whether we were really instilling the idea of scientific rigor at the grassroots, as Kate Button's article suggested. When we were doing our own review of our practice at that time, what we started to notice was an issue within our teaching, whereby students would get to their final year project and they would have absolutely no problem in terms of actually running the analysis. So they'd be able to say, I need to run a t-test or a correlation, etc., etc. They'd be able to run that correlation and regression as long as the data was in the format they required to run it at that point, okay? So they could quite easily take a data set and run an analysis on it, but they were lacking in the skill of actually getting the data into the correct format in the first place, okay? And this is what this slide here suggests, which Dale Barr from our team presented at SIPS conference 2019. The idea of the iceberg of irreproducibility, where students, because of the teaching we were doing in SPSS, which was largely, here's your data, click these buttons, get this result and present it, they were very good at the top half of the iceberg, right? Taking in the final data and analyzing it. But that was neglecting all the prior steps that came before that in terms of taking in all your individual data sets, combining them together, wrangling them into various different fashions. So this bit underneath the surface was the bit that the students didn't see, and this bit up at top was the bit that the students only really ever saw. What tended to happen was that staff members or lab leads would be doing all the work down here, and the students would be doing just this bit up at the top. What we realized there's this knowledge and skills gap brought on by the way we were teaching this research methods, okay? So there was no formal instruction on structuring, transforming, and visualizing data, despite these activities being the most time-consuming, and despite them being the most complex and error-prone. We missed out those steps in terms of our teaching practice and just gave students the final data set. That's not to say that everyone did that, but the majority of Students were well trained, like I said, in running the final data analysis, but were not as good in terms of bringing in the data, transforming it to bring it all together and visualizing it. This absence of formal instruction on these skills led to shallow reproducibility of projects at best. It was not really kind of a well thought out path of how you went from the start of the data to the actual full-on analysis. And this also led to overconfidence in some areas, as well as insecurity and negative self-image, in the idea of like students would get to the end of their 4-year degree or the 4-year degree and be able to run the analysis, but still struggle to actually do the basic data skills, which would make themselves doubt their actual capability. There also was a strong lack of knowledge of reproducibility and issues in our field. There wasn't really any strong formal training on these ideas outside of some lectures on the topics. And if we think about where teaching was traditionally focused in terms of what we were doing, looking at this kind of idea by Gromland and Wickham, a lot of traditional teaching focus back in 2016, 2015 was focusing on this part of the model, right? Communicate and visualize. Maybe some ideas of modeling in terms of running an inferential analysis, but there was very little teaching around about this side of the analysis where all the hard work was done, right? Importing data, tidying it up, transforming it, and then leading into the visualization model. So we wanted to think about how can we readdress the balance here to make sure that students, when they need all these skills down here as well, and not just the skills in terms of communication and modeling, how can we reshape our curriculum to best kind of develop these skills? And again, the premise behind those moves is really to kind of think about, well, this scientific rigor, right? This grassroots skills we're developing at the get-go. The other issue we started to realize that we actually did have some courses where they were teaching the same analysis or approaches, same analysis and same kind of research approaches, but in 2 different software, which was time consuming for people and also didn't really serve much purpose. So Dale Barr in his level 3 course would be teaching kind of the same kind of analytical methods using R and SPSS and letting students decide which one they prefer to use. When we did a bit of analysis based on how people were performing using both R and SPSS, we actually found that students using R were better overall in terms of overall class performance and in terms of homework performance. Interestingly enough as well, their overall anxiety towards statistics and research methods was lower when the students used R than when the students who used SPSS. Now, these were self-selective groups, but it did hint towards the fact that students, when they were given the opportunity to learn more about how the data was coming about and how to work with data better, their overall skills improved and their anxiety towards working with data decreased. A couple of qualitative comments came out from this sort of process as well, and the students were saying things like, we learned the background and theory behind tests that we ran rather than blindly pressing buttons in a lab, which they would have done with SPSS. Additionally, by having to do the homework by hand and having to do homework every week, you spend more time thinking about the materials rather than just kind of trying to cram everything in. So there's kind of a couple of things going on there. The actual process of using R, which allows you to really think about where the data comes from, and the continual assessment idea are 2 beneficial approaches that really help develop students' understanding of data skills. And out of those kind of ideas, the idea of, are we really teaching the skills that we want students to know by the end of our degrees? And by looking at kind of which software is actually best for teaching those skills, the concept of SiteHR started to emerge. And this is really kind of a lot of where we base our research methods and data skills teaching in. And what the kind of principles of are really the idea about teaching essential data science graduate skills, things that traditional approaches to teaching will have overlooked, you know, like data visualization, data wrangling, and reproducible reports. We also kind of make sure we teach more about probability and inference through data simulation, and we do this a lot through using real data sets, and we'll come on to kind of the idea behind some of these moves in a few slides. But really, what is underneath all of this is working with data and research in a reproducible fashion, right? Using the tools that we have to teach the skills that we desire within our students. We want our students to be able to visualize data, wrangle data, and produce reproducible reports. So we need a tool that allows us to make to make that possible, to teach that within our students. Because Dale was already using R, and because actually looking across a bunch of different softwares, it was one of the softwares that allows us to teach the skills in a way that we wanted to teach them. We use R and RStudio. However, we do have to make clear that R is our tool because it allows us to teach the skills we want our students to have. When you're doing these sort of curriculum changes, or when you're thinking about teaching reproducible methods, you have to be clear on what it is you want your students to learn regardless of the software, right? If you don't value data wrangling skills, then there's not really much point in using a software that's built to teach data wrangling skills or allows you to teach data wrangling skills. If all you're really interested in, or what you kind of think is most important for your class that year, is about the inferential analysis, then there are other software that will do that just as well, things like Jamovi and JASP. The benefit of things like R and Jamovi, JASP, etc. is that they are, of course, free and allow students greater independence. i.e. they're not tied to being within a lab, within a building on the university campus. Students can download them onto their laptops and run them from where they are best, from where they're most comfortable, okay? So, although we do focus a lot on using R, we do always kind of stipulate it is the tool that allows us to teach the skills that we want our students to have. And those skills are things like data wrangling, visualization, etc. In order to put this into practice, we also need to think a little about how does someone become skilled. In order to develop skill in anything, you need effectively knowledge about the practice. You need to be able to put, you need opportunities to put that into practice, and you need to obtain feedback on it. So by understanding what you're doing, by practicing what you're doing, and by getting feedback on whether you're doing it correctly, over time, you will become skilled at that task. It is, of course, a two-way arrow, because the less you do it, the less skilled you become. But effectively on the left here, we have the novice, and on the right here, we have the expert. And what we're trying to do within teaching is break down these ideas, or these skills that we want students to have, into knowledge, practice, and feedback to develop them over time. And this is true for any practical skill, including data wrangling, analysis, visualization, placement of citations, report writing, and paragraph structure, etc. Right? All practical skills that you want your student to understand come from the ideas of first having knowledge about it, being able to practice it, and over time, getting feedback on how well they are doing. And teaching is really about breaking down these skills into knowledge and supplying the opportunities for practice and feedback. The added component you have with data skills is the idea of flexibility. And this is something we also keep in mind when we're creating our materials. The skills stay the same, but the data changes, okay? So you can't just keep the same data on every assignment. It makes it easier, but in the long run, the student becomes really trained at using only that data set, where the focus should be on the skill and transferring the skill across data sets. And then from all of that, we started to create our materials. And then all our materials are freely available online at the SiteHR webpage, and you're more than welcome to have a look at them, and please do give us comments and use them as you like. But just to kind of highlight a few examples of what we have in them. This is from one of our courses, and you can see that effectively one of the tasks, for example, will start off by saying, here's how you load in this data set. Now, with the other data sets you have, following the same practice, load in the remaining data sets. And then they have a button down here, which if you click on it, gives a bit more information about how the function works and why we're using certain functions. So it's kind of this idea, okay, the skill that we want students to know is how to load in data, right? Importing data is actually a very beneficial skill, and it's kind of one of these steps that's kind of overlooked many times within research methods courses. So students can actually maybe analyze the data, but they're stuck at the point where they actually need to get the data into a software. So formally train that skill, and through repetition and practice and feedback, they become skilled at loading in data. And quite honestly, if that's all you needed your students to do in that course, then that'd be a really good skill to have them going on to another course with, right? A couple of other notions we have within our teaching. We use a novice-friendly syntax, which has been talked about a lot in the field. We use tidyverse because it allows students to be able to read the code effectively. It's highly based in kind of being able to understand what you're doing at each step as you move the data along a pipe chain. So we found this to be very user-friendly within our teaching. As I said earlier, we use real data wherever possible. This allows students to understand the worth of the skills that they're using. Within psychology, they will cover modules such as cognition, perception, developmental. So we use data sets from all these different fields so that when they're doing the research methods and the stats learning, they're also learning about the theory behind the kind of experiments they're hearing about in those other lecture modules. So it all links together. It develops the idea of worth of research methods and skills and helps reduce the anxiety towards these modules. All our materials are also based around an idea of pre-class, in-class and assignments. So pre-class might be more knowledge-based, trying to generate ideas and give students the understanding. The in-class is more practice-based, and then the assignment will really taps onto the idea of feedback and helping students develop their skills and moving on to the next step. Along the way, we also integrate theory, research methods, terminology, as well as data skills. And we do use formative self-assessment using WebEx package developed by Dale Barr and Lisa DeBryan and the team, and our Markdown to help students understand what's going on, to allow them to check their understanding as well. So you see here in the top left, some MCQs that are within our books where they have to maybe fill in the blanks, enter a number, whatever, etc. And the square goes from like an orange to a green color if they've got it right, or it stays at orange color if they've got it wrong. And then they've got more tabs that they can add, they look at to get more information about the answers. Okay, why do we cite like this? Where did this number come from, etc., etc. So every step, we're trying to help them along in their understanding, and we're trying to show the integration of research methods to the kind of theoretical ideas they're discussing in the other lecture modules as well. And this idea of self-assessment and formative self-assessment just allows them to kind of take it at their own pace, which is, in research methods and statistics, is really beneficial because of the disparity of skill sets that you do have. And then to kind of, as the chapters progress, the complexity within different assignments progresses as well. We start to remove the scaffolding and the hints get less and less, and students are required to do more and more themselves. So you increase the complexity and reduce the hints as the chapters progress. And in addition, we also have the solutions at the end of each chapter to allow the students to check themselves and to move on with their own studying. So you see this task here, where actually there's very little information now on how to complete it. We're just telling them what to do. We may have started them off with some incomplete code chunk. They've got some hint here, they can try it out, and then at the back of the chapters, they will have the solution which they compare themselves against. So at no point should they ever really be stuck about what they can actually achieve, because all the information is there, but it is structured in a way to help them think and combine all the ideas together. And again, we're doing this in our scripts and we're doing this in our Markdown scripts to help with the idea of reproducible research and reproducible analysis plans, tying all the ideas together of what the skills we want students to be able to achieve by the end of our courses. Skill sets of data wrangling, visualization, reproducibility, storing those codes in a sensible manner so that they can look back on them from task to task and from chapter to chapter. And one of the most common things we will tell students is to think back, when did you last do that? When was the last code you ran that worked, that did that function? And it helps them to think about storing codes and making their codes available to themselves, and maybe stepping on to make the codes available to others in later years. So that's the kind of the basic structure of one of our books. And we have books at different levels which are built around the different skills we require students to have at those levels. And they're kind of, the idea is really build the skills as you go, with focus on the students becoming confident and competent at those skills. And really, we want students to build a solid foundation in the key skills at each different level before we move them on to different, more complicated analysis, right? So like in level 1 and level 2, if I kind of show you the description of the overall topics, you will see that data in year 1, we really just focus on things like data wrangling, visualization, probabilities, and some descriptives, as opposed to past years where in level 1, we would be teaching them t-tests, correlations, analyze regressions before they even understood data. In level 2, we will recap these skills, move them on through simulating data, power analysis, more into looking at inferentials using the GLM. Again, solidifying the ideas of data wrangling, etc., before actually kind of leading them into kind of the full inferential analyses at the end of the year. Move them on to level 3, where they start to do more complicated analyses. And by level 4, because they have this solid foundation in the kind of data wrangling skills and reproducibility, they're much more capable at doing really high complex analyses, such as factor analysis, bootstraps, and permutations. I've also shown you here in the middle of the table roughly the number of students we're talking about in each year within Psychology at Glasgow. Ours is a 4-year course, so in the first year about 500 to 600 people, 300 roughly in second year, and about 150 to 200 in both third year and fourth year. Like other courses in other universities, we have quite this diversity in skill sets. Within the Scottish system, students take psychology in their first year along with modules specific to the college that they're in. So a student who's in the College of Arts may be taking English, history, or languages, etc., along with psychology. Social sciences will be taking business and sociology. Science students will be taking biology, chemistry, computing. So within one individual class, you're going to have quite a large diversity of skills, and therefore trying to, one, convince them about the importance of reproducibility and the importance of understanding data skills is quite a challenge. And really being kind of strong on your rationale for teaching these methods, and why, if you want to be a psychologist or even someone that uses data or a consumer of science in the future, you really need to understand where the data comes from. As they progress through the course, they focus more and more on psychology. So in the honours years, they'll really just be focusing more on psychology modules. But as you can see from the kind of the topics we're covering, if you think about, like, as I said, in previous years or that we would have taught, we would have been teaching all these different kind of analytical methods within the first year. But now we're really kind of focusing on the idea of the solid foundation of the key skills. And the idea that it's okay to slow down. We don't have to teach students every different technique within 1 year. We can teach a few things well and make sure that they have that as a solid basis before moving them on to kind of more complex ideas. So that's really how our undergraduate program works. On top of that, we also do have kind of 1 year courses or 1 semester courses for our MScs, where they have quite more different graduate skill sets. So our conversion course, for example, will be graduates from degrees in arts or sciences, with varying goals about what they want out of the course. So that's a 1 year course. And then we've got the 10-week MSc Data Skills course, where we've got graduates from undergrad psychology degrees and neuroscience degrees. And within both of these, we're trying to kind of teach different skills with different timeframes, with different data backgrounds. But really, regardless of the duration of the course, what is really fundamental is, again, teaching the knowledge and the skills you want your students to gain from your course. What all the courses will have, and just want to show this really quickly, is regular assignments in our Markdown. Again, that tests the knowledge and the skills we've been building up, right? This idea of practice and feedback, summative this time. The complexity builds up week on week to help the students understand that they have to continually be building on their skills. And there's a strong notion of the code must be reproducible, right? We don't often give credit to when, like, the code may work, but the variables are using different names. So you'll see a couple of tasks here that will ask them to use a certain name, like stars gather. If they were to change that, but it still gives a similar output, they may not get the credit, because therefore the code is no longer reproducible in terms of the solution. So we're building all these skills into our summative assignments as well. This is what the feedback looks like, and you can see again that we're really strong on the idea of giving individual feedback. So there's the students answering their feedback, as well as the solution and generic feedback. And the generic feedback is really good to be able to reinforce corrections to common mistakes we see, perhaps not in individual students, but across the board. Things like not looking at your output, and, you know, like you'll run a function and it works, but you haven't checked the output to make sure it's given the actual, or it's given a result that makes actual sense in terms of the question. So again, continually thinking about practice and feedback to really build on the knowledge skills. But obviously, these changes are really demanding on staff as well to learn. These are novel approaches and novel ideas. And there are many different techniques you can try doing to get people on board, to bring people on board to think about how they can use these different skills themselves. One technique we've taken is try to integrate things like R and RStudio wherever possible, and to highlight the fact that coding skills benefit staff both in terms of their own research for like the data, the reports that they're putting out, but also things like admin tasks and exam marking or report marking. And this is just an example using the marker package that Lisa DeBryan has developed. So a marker may just fill in a spreadsheet such as this, where you've got different students, each getting their own feedback and grade. And from the spreadsheet, we will develop HTML pages that take all that feedback and generate it into a nice informative feedback for the student. So the marker is no longer having to use individual files for each student. They've got one overall file that creates all the feedback for all the students. And each student gets their own individual feedback, saving the marker time in the long run. What you can also do with this information as well, because it's in a spreadsheet, you can start to do analysis on your own feedback and look at your distribution of grades to see that you're kind of like being consistent across your feedback. And you can also do it to do word searches in case you have to use certain words within your feedback. Excellent, very good, good, etc. And you can use that to kind of make sure that you're hitting all these targets as well and improving your own feedback to help, again, improve the student's understanding of skills. So these are just one technique we have kind of brought on to try and make it easier for people to really integrate with the system. And it's been really beneficial so far. And again, please do feel free to try out all the books and let us know of any kind of feedback or comments you have on them. But I want to shift focus a little bit now, because that's been quite heavy on kind of the changes to the data skills and the coding that we've done in terms of reproducible methods. But it's really the changes changes we have done are not just about coding practices. Around about 2017, when we were making these changes as well, there were papers coming out like this one from Marcus Manafo and the team, thinking about what are all the threats to reproducible science in terms of kind of low statistical power, p-hacking, publication biases, etc., etc. And how could you actually implement ideas to counteract those? These are at the kind of the researcher level, ideas of registered reports, pre-registration, etc., to remove things like harking and carking. But there's also ideas like distributed student projects. And we've kind of been paying attention to these ideas and trying to integrate them into our assignments wherever possible. So assignments based on reproducible research methods to develop understanding and knowledge of different practices. These won't be that kind of different to what people are doing already in their other schools, but I'm going to highlight them just to kind of show people what we're doing and to give you some idea of why we think they're beneficial. Even things like the basic essay really helps develop understanding of terminology, improve critical thinking in the idea, getting people to think about questionable research practices, publication bias, etc., harking as well. So things like discuss whether reproducible research is important to psychology or not. Evaluate whether a many labs approach is beneficial when developing new theory. Evaluate how the task may influence findings in different research methods. Really just kind of focusing on the terminology and getting students to think about them critically. We've also used peer review of preprints, so asking people to look at PsyArchive, etc., and trying to do a peer review of them as if you're actually going to send it to the researcher. This can help show the students that published articles are not error-free. They do have issues within them, and allow students to develop a healthy skepticism of published research. You can also use them really quite effectively to develop writing skills, critical thinking on the methodology, and which was quite surprising to ourselves when we did this, professional courtesy. It's quite interesting to see what people will write without thinking about the person who's on the other side of receiving that feedback. So it's quite an interesting task to do for that. We have done a little bit of analysis on this approach, which you can see through that link there. Other ones like registered reports, where students are given a starter topic and you ask them to develop just the introduction and the methods on a new research question. So this really focuses students on the research question and the approach and not the outcome, to try and move students, the mentality away from focus on whether the effect is significant or not, right? There was kind of a historical approach of where final year students felt disappointed in their own research if it was not significant. Thinking about it in terms of what's the research question and the approach rather than the outcome moves away from this idea. It really helps develop students' understanding of the justification of their research question, right? Building up the theory within the introduction helps understand the design and the rationale, and it can be really used to probe their understanding of these different aspects of a report. It encourages forward planning and thinking about reproducibility from the start of a project and a student. And you can use these as an early level, years 1, year 2, with the idea that when they come onto their final year projects, that they have already got instilled within them the idea that they should plan at every stage ahead. Another good one for doing that sort of idea is secondary data analysis and pre-registrations of known data sets. Often here we use real data from real psychologists that have gathered. And we tend to use ones from our own school as well, which again really just reiterates the worth of the skills that we've been developing with the students. It allows them to think of themselves as researchers as well. Although they've not collected the data, being able to use a secondary data set and analysing that to answer a really important question makes them researchers just as any other kind of student would be. It does also show them that data is big and it is messy, and that findings within a research article are partly based on the decision a researcher makes in the design and the analysis. So just getting them into thinking about how data actually works. And it allows them to learn about documenting analysis plans and deviations from them through kind of things like pre-registration. Added benefit that come from these sort of ideas are conversations and discussions that these assignments spark. So like a common conversation you may have in a registered report would be, well, how many participants would you include? And how do you decide that? A power analysis or looking at previous research? That starts students to think about, well, previous research uses less participants than the power analysis suggests, yet finds a significant effect. And what does that tell us? This then leads on to discussion of issues of false positives, false negatives, replications, etc., in a context that students understand, because it's in a project they're interested in and they're developing themselves. And it allows them to see real issues and real problems and to understand them and think about approaches to them, right? The more you can make the research real to the students, the better it will help them understand what's going on. And the idea of kind of using registered reports and secondary data analysis and getting them to think ahead really kind of reiterates the idea of reproducibility and being able to replicate your projects at a later date. But really what this is all about is just kind of bringing the tools and ideas from our own research communities into our teaching to develop the skills we want our students to have. I'm sure many of you are involved in things like many lab approaches, collaborative replication and education project, which is a kind of many lab for student projects, crowdsource or crowdfunding, crowdsourced data analysis approaches like the Psych Accelerator, reading preprints, the given peer reviews for PLOS, Collabora, PeerJ, etc. These are things we do all the time. And if you look at the skills that we have within them, they're actually the skills we want our students to have. So we may as well bring them back into our teaching and allow students to really understand the issues we face within research. So bringing our community back into our teaching is really important. And the kind of that really nicely leads on to kind of the final point I want to really kind of raise is the idea of building a community. So in any kind of curriculum, you can really change as much as you like, but a sense of community and getting people on board with those changes is vital to making it last. So within the changes we have done over the past year, we've now made sure that group work dominates a lot of our classes, with students working with peers as we would work with colleagues in a lab. This creates support, and support creates trust with people. Support creates trust within people and allows people to become more open to talking about mistakes and errors and asking for help. So kind of just by kind of refocusing your projects onto more group work and collaboration, you start to build this idea of community and accountability, which is really what we want within research practices. We've also got seminars and workshop series that are based around methods and meta-science, open to both students and staff to present ideas and questions. And you can have a look at what's coming up in this series on those links as well. But the changes don't have to be complex. even changing a lab environment from isolated desks to, on the left here, to a layout that promotes discussion, like shown on the right here, really helps create a community. So instead of people working in silos, you get people working in groups and really developing ideas together, right? So it's not about bringing in complex software or bringing in really clever ideas. Really small changes with where you are teaching, the environment with which you are teaching in, can really help generate stronger community. It can really help foster good research practices. We've also got a really strong kind of online support for students through ideas, through software like Slack and Teams more recently in the pandemic. We've got student-led channels where both students and staff can help each other out and help students who are stuck within questions. What we tend to do though is staff don't give answers directly, but we refer students back to previous assignments and previous feedback, just like we would do if we were stuck on a task. So again, the idea of building on the skills, building on the tasks that they have learned, thinking about it in terms of reproducibility, storing your codes in a way that will help you in future assignments, and getting students to look back on those codes is kind of the approach we take when we help students. We also have staff-only channels to help with transition, right? You have to realize that students and staff and students are all at different stages. They're all from different molds, and we all work at different speeds and need different support levels. So in order to help staff and students progress in the transition and learning these new approaches, we have to have environments where everyone feels comfortable with being able to ask for help or a bit of guidance. It's not really appropriate to always have areas where staff have to ask for help and guidance in front of students. So we'll create environments where staff can just ask for help to other staff. That said, it is also really beneficial for students to see staff not understanding things from the get-go as well, and sometimes having difficulty in being able to do a task. So don't be scared about asking questions in front of students as well, or asking students questions, or working with students to get the answers out. Again, it comes down to the idea of everyone working to their own speed, but having the support in there to help people make those transitions. We also employ our postgraduates as graduate teaching assistants in our labs to help both staff and students, and to serve as a link between the two. The GTAs have been really superb in kind of any of the transitions we've done over the last few years. And I think some of the kind of points that they've really helped students realize are things like there's no need to be an expert in this, right? Sometimes you don't know the answer, sometimes you have to Google the answer, and you don't have to always just pretend you know what you're doing all the time. Students seem much more receptive to those ideas when it comes from a postgraduate rather than when it comes from a staff. They are closer in kind of age, and times are closer in terms of experience as well. The GTAs have also really helped develop ideas about reading through the code with students. You know, we're thinking of the pipe function as and then, and going from one function and then, second function and then, third function. So the GTAs are really helpful in getting students to think about reading through the code. The GTAs really came up with a great idea as well. Don't touch the keyboard. It's really easy to just, when a student is struggling, jump in, take the keyboard and fill out the answer for them. It's been harder in the pandemic, but it's still possible. So you always have to remind yourself, keep your fingers off the keyboard. And that was one thing that came from our GTAs, which has kind of been instilled across our board. And it's also really beneficial to have them to always help remind students that we're not about learning R, okay? As we said earlier, R is just our tool. What we're actually doing is learning skills using R. And the more people that you can have on board with that idea, and the more times you can pass that over to students, the better students will feel in the long run about it. What's been really beneficial from all of this and what's come out of it is that our GTAs have now gone on to create their own symposiums and data training word I can't think of, sorry, workshops, their ideas. Yeah, so what's come out of it is our GTAs have been really good and created their own workshops and symposiums. One of these was called Hack Your Data Beautiful, which was they set up for other postgraduate students to learn skills within R primarily. And our own undergraduate course have set up a group within Glasgow University for teaching skills using R to other undergraduates. They started to see the benefits that they were learning within their courses, realizing that students in other courses like biology, economics, businesses were not getting taught these skills. So they set up a student-led group to work with other students and teach other students these skills. So taking those ideas of reproducibility, data skills, and community, and spreading it around their own kind of peers, which is just really awesome to see. But I really just want to kind of end now on a couple of final thoughts to really sum up all of this. Changing a curriculum is challenging, to say the least. My top tip on that is really to be solid on knowing your own rationale for doing it and being able to explain that clearly to your students. To bring anybody along in any change, they have to know why you're doing it and what is the purpose on it. If you're unsure about that yourself, you'll never be able to convince people about it. So to make the best of this change, you really have to know your own rationale and then be able to explain that to any student really clearly. Another thing about these changes is that students want to learn and be challenged, right? And they've chosen your course for a reason, which is most likely interest in the topic. So whenever you're thinking about change and where you think you want to make change, but you're not sure if you can, make the most of these ideas that students want to learn and be challenged, right? And that they have a strong interest in being good within your field. Make the most of that to develop your teaching of good practice within your course. We also acknowledge that there is a learning curve for both staff and students, so try to show the benefits to both parties, right? Students will go along with you because it's the course they want to do, but you also have to remember that staff need reasons to actually make changes as well. So show the benefits to both parties and they will come along with you within your changes. And never underestimate the importance of a community. Students will really benefit from these ideas and students will really benefit from these kind of changes in terms of increased job opportunities and desirable graduate skill sets, right? Things like the Hack Your Data Beautiful Symposium. But student independence within kind of data skills and reproducibility also creates staff time and allows for better projects. I think it has been about 4 years, maybe 5 years since I've analysed any student's data. It used to be kind of historical practice that, like I said at the start, you would tend to do a bit of the work for the students and then kind of analyse, they would do the final analysis. These days, all of my students now give me their code and we run it through and we check it, and that's all we really do. The student does all the coding himself, and what that does is it gives me more time to actually talk to them about the analysis, talk to them about the project and develop the ideas more strongly. Okay, so less time is spent on the kind of the bits that students should be doing themselves, and more time is spent on actually kind of the output. And then lastly, not everyone, we acknowledge that not everyone is in a position to make wholesale changes like we were. People who run like one course in one program may not be able to change kind of everything that they think a student should be able to do. So what we recommend there is just thinking about the one small thing you can change that will benefit your students and changing that. Ideas like essays and reports. If you can only change your essay, then make your essay about reproducible methods and about kind of terminology within those reproducible methods and get students thinking about that. There's always probably something that someone can change if they want to get students thinking about reproducible methods, and it doesn't have to be a big wholesale change like the whole curriculum. So find that one thing and make that small change. It will really benefit your students in the long run. And lastly, I thought it'd be really beneficial to get a couple of student perspectives on it. So here's just a couple of quotes from two of our students. So student one saying, knowing about reproducibility and issues in reproducibility early on in the undergrad has helped me to become more critical about the papers that I read. It's also helped me in designing my own studies. You know the pitfalls, issues that prevent reproducibility, so you know what to look out for. Student two, learning the skills from level 1 has given us the tools to evaluate research when writing essays. It has allowed us to take more of a critical look at papers, methods, and therefore question results. It's an important skill for doing well in coursework. Although challenging at first, perseverance with the principles and tools of open science and reproducibility will open so many opportunities during your undergrad. It's like a muscle group. The more you work at it, the stronger it gets, and you'll see the results. Thinking back to the idea from Kate Button's article in the BPS at the very start, these quotes from our students are really kind of pleasing, I want for a better word, to ourselves, to know that our students over a 4-year period are really benefiting from this instilling of scientific rigor at the grassroots that we've been working towards. So a couple of conclusions in terms of kind of developing a curriculum around reproducible research. Identify the knowledge and skills you want your students to have. Identify the tools and assignments that allow you to teach those aspects. Try to integrate them into teaching, research, and admin as much as possible to help with transitions. And overall, everyone benefits from teaching based around reproducible methods as the skill set goes beyond the classroom for both staff and students. Lastly, just to say these changes have truly been a team effort between staff and students, and every single one of them should be thanked for helping to improve our research methods in our school. Special mention, however, goes to the SiteHR, or the people that set up the SiteHR to begin with: Dale Barr, Lisa DeBrine, Emily Norman, Helena Patterson, Lee Stack, and Heather Cleland-Woods. Every single one of us is on Twitter, so do please let us know if you have any comments, questions, or ideas. We're always happy to take feedback on any of this. Thanks very much for listening.